Okay, can you guys at home hear me? Yeah? Okay, thank you. All right, guys. So, guys, we've already been chatting for 15 minutes, so I'm a little concerned about getting through everything right now. Tammy.
So the filter funnel, you have solid liquid in the cup, and then you pour it through.
Yep.
And what comes out on the bottom?
The liquid.
Liquid. No.
And then the solid is trapped on the top. So we have a filter funnel on this side, and what this does is if you have a solid and a liquid mixed together here, you know, like if you have like dirty water, you can pour it into a filter and it'll keep all the solids up here, the dirt and the bugs and fish, whatever. I don't know, what kind of dirty water do you guys get? And then you can have liquid that comes out at the bottom. The way distillation works is instead of just pouring something into a filter, what you're going to do is heat up a sample of something. And then if it's possible for something to boil away, it's going to rise up into this tube. Generally, these little pipes here are where you have water going in and out. Generally, you have it going in at the bottom and out at the top. And this cools the gas that was rising inside the flask, and then it drips out as a liquid in the bottom. Do you guys know what distillation usually gets used for? Yeah. Yeah, usually for making consumable alcohol. I use this for part of my dissertation because what I was doing was taking fossils and grinding them up and then extracting out pigments and biomarkers from them. And so I would regularly have a solution that had fossilized pigments in it, and then I would evaporate the water out so I could concentrate the pigment in the liquid that was left. So you can use this for not alcoholic means, but that's what this is actually famous for at this point. So which one do you think would be most useful to separate sand from salt? You guys ever thought about that? Why do you think distillation?
Well, because I normally think of like a filter funnel using like, well, wait, isn't like, aren't they both solids?
They are both solids.
Yeah,
Grace.
I think salt is like it has bigger volume than sand and smaller, so it makes sense I think to use the filter tunnel because the sand would go through but the salt wouldn't. So maybe that's wrong.
Yeah, so if your grain sizes were different, you might just be able to use like a sieve to be able to filter them out.
Yeah.
So think about it like this too. If you've got sand and salt, do they have different properties? Have you guys ever been to the ocean?
Yeah.
Where's the sand?
On the beach.
Where's the salt?
In the water.
In the water. So if you have sand and salt and they're mixed together, couldn't you mix that solution with some water and then filter it out and have the sand left behind here? And then have salty water down here? Yeah. And then you can take your salty water and put it over here, evaporate your water off, and you're just left with your sand in your flask.
Oh, so the dirt's
That was a trick question.
Haha.
Wow.
Grace is accusing me of trick questioning people at home. I don't know if that's true. What about if you could you use the filter funnel to separate salt and sugar?
No.
No, why not?
They look they're the same.
Yeah, both of them will dissolve in water, so you'd have to be extra tricky to separate salt and sugar.
Just take you, no.
You just have to
Just takes a kind of
No, have you ever been baking and accidentally mixed up salt and sugar?
I see it all the time on baking
I know.
shows.
It's bad, right, Aaron? Irrecoverable. Absolutely irrecoverable. Luckily, both of them are relatively cheap nowadays, so that's okay. In the past, they both used to be very expensive. All right. No. Please no. There was a person.
Really? Someone actually did it?
Well, there was a person last year that did a taste test, which firstly, taste test, bad science fair idea. And then she literally brought like 4 dozen cookies to science fair and had them sitting out at her display. And so I had to be the one to tell her. She had to put all of her cookies away because
I remember seeing her.
they were considered hazardous, which I felt bad for her.
Give us cookies.
But honestly, you know the thing about the adult sponsor where it says your adult sponsor has read all the, like, her teacher told her to bring cookies. Like,
Yeah, wait, with all that science stuff around the air, can't you typically not actually bring the cookies?
what?
Oh, like taste test.
Yeah, her teacher was like, she told me her teacher suggested that she bring the cookies because it would be a good thing to have sit out and it would draw attention to her project.
It did because I wanted cookies. Drew attention to me.
All right. So particle representations. You guys are just kind of seeing all these, right? So if
Hello, Valley.
yes,
Is Timberland James in your room?
yes.
If she left yet, she's supposed to come to the office.
Okay.
Thank you.
Yep. All right. So iron and sulfur. I've got a jar of iron and a jar of sulfur. So this is iron filings. So if somebody took a big chunk of iron and just shaved off parts. And this is sulfur. Now, I know that you guys at home can't see this super well, but like it's like super bright. You guys see it here?
Yeah.
It's like neon yellow. Neon yellow. Okay. So if we took these two things and thought about what would happen if they were just particles and they were mixed up, we would expect to have something like this, where we've got individual particles that are evenly distributed in space. The way I was thinking about these as the dark ones are iron and the light ones are sulfur, but you can go either way, I guess. Iron and sulfur. This would be a mixture because they're not combined, they're not attached to each other. They still have their own individual properties, and theoretically you could separate them. You guys know how to separate them? Okay, so there's my iron, right? I get some iron in there. Iron. Some sulfur. Oh, it's so beautiful. How do I separate the iron out? Shake it? What was that? Mia says use a magnet.
Oh yeah, that would be a great idea. Because iron, iron shavings are attracted to it. And then you shake it.
Shake it. It's even like got a chunk in there. Hold on. Here we go. Isn't it beautiful, guys? Yeah, so what property does iron have that sulfur doesn't? Magnetisness. Yeah, that's right. Magnetisness. Okay, so I can take that iron off if I pull my magnet off. If you ever do a project like this, you can't let the filings get on your magnet. You'll never get them off. Yes, I am speaking from experience. No, we should not. Okay. All right, listen, guys. You listening?
Yeah.
All right, listen.
No. I'm so confused. Wait. Is that just a little straggler?
Yeah, did you hear him though?
I did.
By the way, if you do this with your breakfast cereal, you'll get iron filings too.
No.
Yeah, that's how they iron fortify cereal. They just put iron filings in it.
Is cereal identical?
Yeah, if you take cereal, especially from the bottom of the bag, and you crush it up and you run a magnet through it, you'll get iron filings. For sure. There we go. Did I do okay? I got a bunch of them out. Oh, I have to be careful because I did this earlier too, guys. I got this way too close.
Sure. Whatever you say.
But you can kind of get more sulfur. It looks like a truffula tree. Oh. There we go. Iron filings. So we can still separate those. But the thing is that if you know stuff about earth science, you guys all take earth science in junior high, hopefully. Excuse me while I go cry about the sadness of you guys not taking geology and earth science. Yeah, okay.
The closest thing that earth science I got was a fossil in, and then you did a textbook definition of
Yeah, I'm gonna go
There's
weed.
halfway and there's all the different.
All right, guys.
variants.
So if you have iron and sulfur and it forms a compound, the most common one that it'll form is this thing called FeS2, which is iron sulfide. Iron sulfide is the same as pyrite. Pyrite is fool's gold. Interestingly, it comes from a yellow element, so that's kind of what gives it its color. Makes it look golden. Very fancy. So to draw your particles of a compound, you have to draw your dark and light so that they're attached and connected to each other. They do look kind of Mickey Mousey because they've got unbounded electrons, and so that's reflected in their mineral structure, but that's more geology than you guys actually need. Fool's gold. Yeah, they're also cubic. So if you get really lucky and you go to a mineral show, you might be able to get a sample of pyrite that is a perfect cube. It's one of those things my husband and I have gotten into arguments with people about because they say things like, there's no such thing as a straight line in nature. And of course there is.
What would there be? There's such thing as anything in nature.
Yeah.
Anything.
I mean, that's hard to disprove, but
Yeah. Just because you haven't discovered it doesn't mean it doesn't exist.
there's a lot of things I haven't discovered. Okay, so a magnet can separate iron atoms because the attractions, sorry, from the mixture and not the compound, because the attractions between the atoms in the compound are stronger than the attraction of the iron atoms to the magnet. Does that make sense? So in the mixture, these elements don't care about each other. They're not gonna hang out together. They're not partners, nothing like that. If the iron is attracted to a magnet and the sulfur is not, and a magnet's in the area, the iron's gonna be all, see ya, take off and go stick to the magnet. But if it's bonded to the sulfur, it sort of loses those magnetic properties.
So then is it no longer attracted to the magnet?
It's no longer attracted to the magnet.
Oh my goodness gracious.
Yes. Poor magnet. All alone. So this sketchy thing I have to deal with now. All right. Sorry, I have like sulfur dust all over me. And now it's on my black pants. Great. All right. So you guys have any questions about that page? All right. Now we're gonna argue with each other.
Yay. I do that either way. So like.
All right. We've got 4 containers. Which ones are mixtures? A is a mixture.
B is definitely a mixture.
Why is B definitely a mixture?
Because even though there's some bonded to each other, there's some of different types that aren't connected at all.
Yeah, I mean, these aren't all the same, are they?
Yeah. B and D and D.
And D is a mixture because these aren't all the same. Are these all the same?
They are, yes.
Are these all the same?
Yeah.
All right, so we're going to say B and D are mixtures. A and C are pure substances. Trying to not give up. All right. Which one has only compounds?
A.
A? A and D? Does everybody agree with that?
Does a compound, can a compound, no, well, can a compound be a mixture?
Can a compound be a mixture?
A compound because it isn't a mixture, so B is a mixture, B is a mixture. C isn't a compound because it's, right. A compound is
Let's
the
see.
opposite of a mixture.
So this says a compound is a chemical substance composed of many identical molecules, composed of atoms from more than one element held together by chemical bonds. A molecule consisting of atoms of only one element is not a compound.
Which means it's just A because only elements.
So then this one is a compound. This one is not a compound. Is it a mixture? Is C a mixture? No. not a mixture. This is a mixture. This one's a mixture.
Meredith and I aren't arguing about it. We've come to a compromise. We prefer not to argue.
Yeah. And C is actually only elements. So the way that we know that, or a way that we can think that through, is a lot of gases are diatomic, right? And this is particles that are free, that are distributed in space, and they're not really bonded to each other. Yeah.
Why would D be a compound? Because we said that D was a mixture and that they can't be a mixture and a compound.
Because it has only compounds.
Oh, I see. Well, then you're wrong on the test.
What test?
Nothing.
You guys time travelers?
What?
You guys time travelers?
No. I'm pretty sure legally all
But they have a time turner somewhere. All right, which ones are mixtures and which ones are pure substances?
Pure substance, D.
D is pure. I'll buy that.
You know?
Is C a mixture?
C looks very mixture-like. I'm going C is a mixture. B's are not all connected, so I'd say B is a mixture.
Yeah.
B and C. Where's A?
Is it A cube?
A is a solid. Look at that.
If it's a solid, then that means that because it's not all one substance, then it would be compound.
Think it's a compound?
Yeah, I think B and C are the only mixture.
I think you can make an argument that it's a compound because it's two different elements that are bounded together.
Yeah,
right?
That's the definition of a compound.
Can it be a pure substance?
Well, does pure substance have to be only one element?
I don't know.
Why don't you know? You're the teacher.
Okay, so think about this. Do you guys know what table salt is?
Yeah.
Okay, what's the formula for table salt? NaCl, right? So you've got two elements. Can you have pure table salt?
No, that's just sodium. Isn't that explosive?
Yeah, sodium is explosive.
Yeah.
But can you have pure NaCl?
Well, yes, if that's what you're trying to do, but it's not really pure.
Why?
Because it's multiple substances. I'm gonna say A is not pure.
You think A is not
I
pure?
don't think A is pure. Yeah, because it's got different colored.
Yeah, we like to argue about this, don't we?
What's the difference between pure substance and pure element? Is there a difference? Because D is a pure element, but just one thing. Well, a pure element would also just be one thing. So is a pure element the same as a pure substance? Are they synonymous or are they different? Because D is a pure element. But if D is both a pure substance and a pure element, we know that D is a pure substance because it's a pure element. But can you be a pure substance without being a pure element? Yes or no? No. I don't know.
So are you saying that the only things that are pure are things that are made of a single element?
That's what I'm saying. That can you have a pure substance without it being a pure element?
What do you think?
I think that you can, because if not, then why would you have two different words for it?
Yeah.
Why would you have two different words that mean the exact same thing? In which case, A would be a pure
Hi, Mia.
substance. Because do we know what it means like?
Hold on a second, guys. What was that, Mia? Oh, go ahead.
Well, I think pure elements are just one of the elements.
Just one? Yeah, this is a pure element right here. But this has got two elements. So the discussion is, can you have something that looks like this that's still pure?
Well, I don't think that pure substance and pure element are synonymous. So
Yeah.
maybe that means I think yes, they can, like pure substances can be two different ones.
Yeah, that's what I think too.
Yeah.
I think you can have a pure substance this looks terrible on the screen. That's one element, or it can be a compound. Right? Or it could be something like this. Because you have anything that so think The example that I gave here was table salt because it looks a lot like this when you look at the atomic structure of table salt. But what about sugar? Do you have pure sugar? What about Tylenol? Do you want your Tylenol to be pure?
Probably not.
You don't want pure Tylenol?
Absolutely not.
Put all kinds of junk in it.
I did a science run.
No, don't do pure alcohol. You'll die.
A pure substance or chemical substance is homogeneous with constant properties throughout. That is the definition that I got on thoughtco.com.
Cool. Does this look homogeneous?
Yes,
Yeah, I think so.
which means it's a pure substance. I cheated, I win.
It's all right. You can cheat by looking on the internet today. That's all right. All right, so I put B and C were mixtures. You guys didn't really have a problem with those at all. I put D was a pure substance. You guys didn't have trouble with that, and I put a question mark on A because we like to debate about that, right?
I'm saying that A is a pure substance.
Do you guys all think A is a pure substance? What? I think that this is a pure substance, but it's fun to argue about it.
That's such a stupid argument. But then what's the actual answer?
I think it's pure.
It's wrong.
There, does this help?
No,
There you go.
okay.
Okay. So it says which contain only compounds. That's a compound. Does this contain compounds?
Well, we said no.
No. Does this have compounds?
Yes.
Yes. Does this have compounds?
No.
No.
Only elements is just D.
Just D. That's it.
It's a pure element.
That is correct. More things.
Yay.
Thank you, Grace. I appreciate that.
You're welcome.
Oh, why this is also dark. All right. So in this first one, we have something that really looks a lot like a diatomic gas. What do you guys think about the second one? Is it a compound?
It looks to be, because all of them are connected, and all of them are connected to only one.
Why are they so close to each other in the picture?
Because they're liquid.
It might be a liquid or a
Because
solid.
they're probably a liquid. That's not what it's called.
Oh, never mind.
That's,
Yeah.
yeah, solid.
A liquid or a
Solid,
liquid,
solid,
right?
solid. Oh, sorry, I gave this one up. This one's a solid. Solid. I wrote metal there too.
Wait, would the other two be gas then?
These two?
Yeah.
Yes. Yep, so those two are gas. Is this compound or mixture?
Compound.
Compound.
Compound. Which ones are mixtures? None.
Is A what oxygen look like?
Yes. Oxygen, nitrogen, hydrogen.
Oh, I see that.
Helium is not diatomic.
Aren't all of them pure substances?
Yes.
Well, I didn't look up there. I came to my own conclusions because that's why I do.
Yeah, she's Googling everything.
I Googled one thing. It was after we had the argument on it.
Okay. Which ones have only compounds?
Two, B and C. About to say 2 and 3.
Yeah, A doesn't. We were having an argument about that earlier. Which ones have only elements? A and D. And then the last one, we already covered this. Which ones are gases? A.
A and C.
Yeah, because these are not associating with each other in any way. B is a liquid because they're all kind of sticking together, but they're close to each other, but they're not in an orderly arrangement. And then D is a solid because it's in an orderly arrangement.
Good job, us.
Gold stars. All right, what questions do you guys have? It's like a pen rocket. You guys do this, right?
I'm prepared to always have to read those. That's nice.